Hey there, Delphi FMX developers. You know that amazing feeling when your cross-platform app starts coming to life, but you also know that sinking feeling when the UI just doesn't feel crisp, right? Well, in this explainer, we're going to turn that frustration into pure performance satisfaction. We're diving deep, really getting into the nuts and bolts of how to make your FMX apps as fluid and responsive as they absolutely deserve to be. You know exactly what I'm talking about, don't you? That tiny hesitation on a button press, the stuttering scroll in a list, that animation that just kind of jerks its way across the screen. It's that sluggish feeling, that lento vibe. It's probably one of the biggest headaches in cross-platform development, but here's the good news. It is completely solvable. We just need to understand what's really going on under the hood. So before we can fix this, we've got to give it the right name. We're fighting UI jitter. And it is super important to know this is different from jank. See, jank is like a one-time thing, a single skipped frame because something stole the CPU for a split second. But jitter is worse. It's that constant rhythmic stutter that makes your whole app feel broken and unreliable. And fixing that means we have to look way deeper than just one slow function. All right, here's our battle plan. First, we'll nail down the symptoms of this jitter problem. Then, we're going for the biggest win, upgrading the graphics engine. After that, we'll become masters of asynchronous tasks to keep that UI thread happy. Then we'll fine-tune with some component and memory tricks. And finally, I'll wrap it all up with a clear, actionable roadmap so you know exactly what to do. Okay, first things first, let's get on the exact same page about what this problem actually looks and feels like. The tricky part is that these symptoms pop up during the most basic user interactions, which is exactly why they're so harmful to how people feel about your app. Any of this ring a bell? That stutter when you're trying to scroll through a long list? Or how about that annoying flicker around the edge of a window when you resize it? Or maybe that tiny, but you can feel it, delay after a tap that makes the app just feel disconnected. These are all the classic signs that your main thread or your rendering engine is just completely overwhelmed. And this isn't just about looks. It's about whether your app feels professional and solid or amateur and buggy. All right, let's jump into our first major solution. And believe me, this one is a total game changer. Think of your app's graphics engine like its heart. If the heart is weak and struggling, the whole body is going to be slow. For a while, FMX had some default engines that were, well, they were okay. But today, we have options that are just in a completely different league. So check this out. We're looking at two massive upgrades here. First, for all you folks on Apple platforms, the old core graphics renderer is just slow. A lot of the time, you're lucky to get 20 frames per second. But just by switching to Metal, Apple's modern graphics API, you can leap to a rock-solid 60 FPS. It's night and day. Second, for all platforms, the default FMX canvas can be a bit of a gamble. By switching to the Skia engine, which, by the way, is the same engine that powers Google Chrome, you get one unified, super-fast rendering pipeline everywhere. Now, let's just take a moment to appreciate how much better Skia is. We are not talking about a tiny 5% improvement here. You could see up to a 50% raw performance boost. But it's not just about speed. The visual quality is on another planet. We're talking smooth, anti-aliased lines and incredibly crisp text that looks amazing on any screen. And here's the real kicker: consistency. You design your UI once, and you know it's going to look and perform beautifully everywhere, because the exact same engine is trying. So how do you unlock all this awesome power? You're going to love this. For a lot of apps, it really is as simple as this one line of code. That's it. You just drop this into your project's main source file before anything else initializes. And you've told FMX to use the powerhouse Skia engine for everything. Every label, every shape, every single control. It is probably the highest impact change you can make for the least amount of work. Okay, so our rendering engine is now a beast. What's next? We need to tackle the #1 killer of app performance, a blocked main thread. See, your entire user interface, every button, every animation, it all lives on one single thread. If that thread gets busy doing anything else, your app will freeze. That's it. Game over. This is the root cause of UI jitter and that feeling of unresponsiveness. And hey, don't just take my word for it. This quote from the developer community on Stack Overflow absolutely nails it. One of the biggest mistakes we see is the misuse of tthread.synchronize. You think you're being clever by putting heavy work on a background thread, but then you wrap the whole thing in a synchronize call. All you've done is force that background work to run on the main UI thread anyway, completely defeating the purpose and causing the very freeze you were trying to prevent. Let's look at this visually. On the left, that's the anti-pattern. That synchronized do work inside a loop is a performance catastrophe. It literally stops everything and forces the main thread to do the work. Your UI is completely frozen. Now look to the right. This is the right way. We spin up an anonymous thread, let it do the heavy lifting in the background, and when it's done, it uses tthread queue. This is the magic part. It's non-blocking. It just politely leaves a note for the main thread saying, hey, when you have a free moment, please update the UI with this. All the while, your UI stays perfectly smooth and responsive.
So let's make this simple. You need to live by these rules. Your main thread has one job: keep the UI fluid. Anything heavy, reading files, making network calls, hitting a database, has to be pushed to a background thread. Use T-task or anonymous threads. They're your best friends. And please, please avoid application.process messages. It feels like a quick fix, but in FMX, it's a trap that can lead to all sorts of weird bugs. The modern, safe, and correct way is to use background threads and update the UI with tthread queue.
Okay, awesome. We've upgraded our engine and we've freed up our main thread. Those are the huge architectural victories. Now it's time to zoom in and look at the finer details. The specific components you pick and how you handle memory can make a really big difference, especially on phones and tablets. Now this is a classic FMX mistake. TListBox and TListView might look the same, but they are worlds apart under the hood. Every item in a TListBox is a full-blown, heavyweight control. If you have a list with 1,000 items, you're creating thousands of objects that FMX has to manage and paint. It's a recipe for scrolling jitter. TListView, on the other hand, is virtualized. It's smart. It only creates the visual bits for the items you can actually see on screen. So the rule is simple. Short lists of maybe 10 things, TListBox is fine. Anything longer, you must use TListView. No exception. Beyond just components, FMX gives us these awesome global flags that act like a master control panel for the rendering engine. We already talked about global use metal. That's a must for Apple devices. But you can also try global disable focus effect to get rid of the focus animation, which helps on older hardware. Global use HWFX is great because it pushes things like blurs and glows onto the GPU, which is what it's designed for. And global event-driven display updates is a fantastic battery saver because it tells the app to stop redrawing the screen if nothing is changing. Playing with these is an easy way to get some quick wins.
And finally, let's quickly talk about memory, specifically bitmap memory. A loaded image takes up way more space than you might think. The formula is simple: width times height times 4. If you've got a long list with lots of big images, you can chew through RAM really fast. This causes the system to start cleaning up memory, which leads to those sudden jarring freezes in your app. The pro move here is a caching strategy. Keep your images on disk and only load the ones that are visible into a small memory cache. This keeps your memory footprint low and your scrolling perfectly smooth.
Whew, we have covered a lot of ground, from high-level architecture all the way down to little tweaks. So let's wrap this all up into a simple, prioritized strategy that you can take back to your own code and start using right away. Here it is, your 3-step roadmap to a high-performance FMX app. And please, the order here is critical. Start with number 1, always. An unresponsive UI is the worst possible user experience, so your top priority is to get everything that isn't UI-related off that main thread. Once your app is responsive, then you move to step 2. Upgrade your graphics engine with Skia and Metal. This will make your app not just responsive, but beautifully fluid and fast. And finally, once that solid foundation is in place, you can move to step 3 and start fine-tuning, swapping out components like TListBox and tweaking those global flags for that last bit of performance. And that brings us to one last thought to leave you with. For years, the whole cross-platform debate was about a trade-off, right? You could have one code base, or you could have true native speed, but you couldn't really have both. But as we've seen, tools like Skia and direct hardware access through Metal are completely changing the game. They let FMX deliver performance that is so close to native, most users would never tell the difference. It really makes you wonder, is that old compromise finally a thing of the past? It's a pretty exciting time to be a Delphi developer. Thanks for joining this explainer.